Hello, hello. Am I audible?
Yes, ma'am.
Okay, so we'll start. So, in the previous lecture, we have started the peak microcontroller and we have completed the architecture and the basic features. Apart from that, the basic difference between 8051 and peak microcontroller. Okay, so just I will revise the features of peak microcontroller that are very, very important and which are different other than 8051 microcontroller. So, the hardware architecture, then the basic important thing is related to the frequency 0 to 40 megahertz frequency is available. Then the external interrupts, then the timers. So already we have covered. I will just revise the features. Then MSSP model is there. Then the ADC is available on chip, which is not available in 8051 microcontroller. Some of the facilities are available for the low volt detection. So LVD, brownout reset is available. So all these features we will see again in detail one by one. But right now you should know what the peak microcontroller consists of on chip and how it is different from 8051 microcontroller. Okay, then power on reset is available. Most important timer available with peak microcontroller, it is called as a watchdog timer. It continuously keep watching the microcontroller activities, and if it goes in the infinite loop, so from that it can prevent. So that's why the name is watchdog timer. Then obviously the programmer controller can be programmed through ICSP, that is in circuit serial programming pins. So that protection, that facility is available. The most important thing is the peak microcontroller and 8051 microcontroller both are 8-bit microcontroller. That is the same thing, means they can handle the 8-bit of data at a time. Okay. आता लगेच हां. So this is the basic, you can say, block diagram of the peak microcontroller. Then we have seen the microcontroller and then the memory, some of the registers, ALU, WREG, that is the working register, status register. So number of registers are available, and as this is a hardware architecture, so program memory and data memory is different. So for that purpose, different address bus and data buses are available. Okay, that is the different thing apart from the 8051 microcontroller. So what I suggest in the last lecture also, you should do the comparative study, then and then only you will get the proper clear understanding about the peak microcontroller. Otherwise you will get confused between 8051 and peak microcontroller. During the lectures also I will just give the differences or comparative statement between these. Okay, 8051 is a one human architecture where program memory and data memory is same. So that's why only one address bus and one data bus is available. Here the data bus and address bus for program memory is different, and data bus for address bus for the data memory is also different. So that we have seen 21-bit address bus, 16-bit data bus for program memory, and 12-bit address bus and 8-bit data bus for the data memory. Okay, then we have seen the control architecture in detail. So I will just give the brief introduction about what it consists of. So obviously the arithmetic and logical unit, that is the ALU, the status register is available. This is very, very important register which is called as a working register. It is same as that of your accumulator in 8051 microcontroller. Okay, so what is the job of accumulator in 8051? Same job is performed by working register in peak microcontroller. Okay, then the program counter, the new concept is in a peak microcontroller is BSR and FSR, so which are not available in 8051 microcontroller because the data memory structure is very simple in 8051 microcontroller. So we will see what do you mean by BSR and what do you mean by FSR. They are the registers which are used to access the data memory and the control unit. Then address bus, so right now we have seen the diagram. So address bus, a 21-bit address bus for program memory, the according to that the capacity will be 2 megabytes of memory. So all of you know, depending upon the address bus, how much maximum memory can be accessible, that we can decide. So 2 to the power of 21, that comes 2 megabytes of memory. Okay, 12 bit of address bus for the data memory, addressing capacity is 4 kilobytes. Okay, so these are the address bus for the program memory and address bus for data memory. Similarly, data bus for both the memories, 16-bit data bus for program memory and 8-bit data bus for the data memory, and the control signals are read and write signals. Okay, so then apart from that, we have seen कि peak microcontroller has total 5 ports, A, B, C, D, E. Okay, and apart from that, they all pins are multiplex. So now you know the meaning of multiplex pins. Okay, so the same pin can be performed the number of operation, but the basic operation is IO pin, input output pin. Apart from that, some functions are assigned to that pin. That's why they are called as a multifunction, or the pins are called as a multiplex pin. Okay, so each port is identified by a separate SFR, that is the special function register. How to access the port? The specific register is allocated with that, and here in 8051 the name of the port is port A, port B likewise. In 8051, what are the names of the ports? We have seen P0, P1, P2 likewise. Okay, so here the name is port A to port E. Okay, so total 5 ports are there. So timers are there, serial communication, USARTs are there, A to D converter is there, parallel to slave port is available, and data EEPROM is available. That we have seen in the features. Okay, then the instructions are 77, almost 77 instructions are there. Why? Because it is a RISC architecture, so the number of instructions are reduced. So CISC and RISC, we have seen the difference between that. So this is the organization of memory. In that, first of all, we will see the data memory organization, which is very very important. Okay, so while accessing the data memory, there are three parts, the three ways to access the data memory: direct using bank select register, that is called as a BSR; indirect using FSR, that is the file select register; access bank using general purpose register, which is called as a GPR. So as far as this 8051 is concerned, data memory is nothing but your RAM memory, internal RAM organization, and data memory is same. Okay, so there we can directly, the banks are available, and directly we can access by selecting a particular bank. But here the three ways to access the data memory is available in peak microcontroller. So these are the three ways, we will see one by one. So see, this is actually the organization of data memory. So what you could see in this data memory organization, again the number of banks are available. Okay, so as the data memory is 4 kilobytes of data memory, this particular memory is divided into total 16 banks. 0 to 15, total 16 banks are available, and each bank is of 256 bytes. So you can do the calculation. So 256 bytes into 16, it comes around 4096, that is 4 kilobytes of memory. Okay, so total 16 banks are there, whereas in 8051 microcontroller, how many banks are available? Only 4 banks are available, bank 0 to bank 3. Okay, so in this way, the data memory is divided into these particular banks. In that, bank number 0 and bank number 15 has a special feature that is divided into again two parts. Half part of bank 0 and half part of bank 15, it can be used as a general purpose bank memory. Okay, and next part is in bank 0, it can be a access RAM, and in bank 15 again it can be access SFRs, that is the special function registers are allocated with this. And the combination of these two, that is the bank 0 and bank 15, the half part, it combines a complete bank, that is called as the access bank. Okay, so just draw this organization first, then you will get the idea. I will be back within a couple of minutes. Okay, so try to draw the diagram data memory. Okay, हेलो,
यस मैम।
निकाला क्या?
मैम वो पीपीटी विजिबल नहीं था मैम।
ओके ओके, ठीक है, मीटिंग के लिए मुझे 2 मिनट जाना पड़ा, ठीक है। अब देख लो पहले। सो
मैम क्वेश्चन था मैम।
हाँ, हाँ बोलो।
मैम अभी हम लोग 8051 और पिक कंट्रोलर पढ़ रहे हैं।
हाँ,
मैम तो अभी पिक कंट्रोलर करंट मार्केट में यूज होता है कि मैम ज़्यादा आर्म
in
कंट्रोल।
most of the cases peak microcontroller is used. Still 8051 microcontroller is used for small application, though it is a basic, but in advanced version arm based microcontrollers are used. But see, as per the syllabus we have to study. Rather, for mini project we are insisting ki go for peak and other microcontrollers, not 8051. You cannot build your mini project by using 8051 microcontroller. So either you should go for peak microcontroller, or you can go for the AVR microcontroller. Yes.
ओके मैम।
But peak microcontroller is most reliable microcontroller, as number of features are available with it. So number of projects, prototype projects can be built by using peak microcontroller. And don't think 8051 has no use, but still in some small application where the requirement is less, the 8051 microcontrollers are in use. Okay. And so as to get the confusion between both the microcontrollers, try to do the comparative study. So in the while teaching also I will explain, while explaining the data memory, suppose what is the structure of data memory or RAM organization, both are same in 8051 microcontroller. How many banks are there in 8051 microcontroller for data memory, same in peak microcontroller. So likewise you have to study, otherwise there will be a confusion. Because in end sem exam complete syllabus is there, and so the questions will be from 8051 as well as in peak. For oral also, some of the practicals will be on 8051 and some of the practicals on peak microcontroller. So theoretical part should be understood properly. Okay, is it okay, Tejveer?
यस मैम।
Okay, should I continue?
यस मैम।
Okay, so see, this is the data memory organization. In that, 15 banks are available, and the most important thing is different parties. Some part of bank 0 and some part of bank 15, they are combined together, and that is called as a access bank. Okay, remaining banks can be considered as a general purpose bank. Okay, now we will see how to access that. So for a peak microcontroller, so this is the structure. So this is the ALU, arithmetic and logical unit. So F is from file register and W is your accumulator. So the operations can be performed, and depending upon that, the either the result will be stored on working register. Again, if it is required for proceeding for further processing, again it will be defined, it will be taken for that. Otherwise, the through data memory to the data bus, it is available on the data memory. Okay, so here the most important thing is a bit is available. If a is equal to 0, the access bank will be accessed, and if a is equal to 1, use the BSR, that is the bank select register. So different banks can be accessed. Okay, so this is the access bank, and actually the access bank is a part of your data memory bus, but only half part of bank 0 and half part of bank 15 combined together and forms the access bank. Okay, so we'll take one example, then you will get the idea. So that you have to remember, a is equal to 0 access bank and a is equal to 1, use the BSR, that is the bank select register. Okay, so this is the opcode according to that. So this, there is a bit, so depending upon the value of a, 0 and 1, the particular bank get selected. Now see, here I have taken one example, that is the structure of data memory, number of banks are there. If A is equal to 0, A is 0 here in this case, and 4-bit BSR register, and the particular bank address. So the address is 82. That is the from bank 0, the or bank 15, any bank, the particular location from that bank. So this is called as 0 cross 82. So this is the 82th location. But the thing is, we are not bothering upon about the bank select register. So when a is equal to 0, the bank a is equal to 0, we will be accessing the only access bank. And you just see carefully, access bank is a combination of bank 0 and bank 15. Okay, so here in the case, as a is equal to 0, the only option is I can access this bank 0 part, or I can access the bank 15 part. Okay, so here 82 is the location given, so that's why it is showing to that particular location, irrespective of other bank, irrespective of the bsr. Bsr is nothing but the bank select register from which you can select a particular bank apart from the access bank. So as to select that part, your a value should be 1. So right now a is 0. So as I know, the opcode or instruction size is about 8, 10000, that is 8, and 0010 is 2, 82. So that particular location I am accessing. Okay, now again I will take one example, then you will get the idea. So this is related to when a is equal to 0, what are the possible bank that you can access? Half part of bank 0 and half part of bank 15, that's it. Because the access bank is formed by that two parts only. Okay, now we will see one example. See this carefully. If a is equal to 1, so what is the meaning of a is equal to 1? We are selecting the bank through bank select register. So in earlier case, bank select register is not activated. We are not bothering about its address. Now here we are bothering about its address because the a value is 1. Now the BSR is 0010 means 2. So what is the meaning of this 2? Bank 2 is selected. And again in bank 2, which particular location you want? That is 82. So that's why the total address will be 282. So first bit is for particular bank, and next two bits are the location from that bank. Are you getting this? So this is the significance of data memory, which is very, very important. So number of times the theoretical question will be asked in your NSEM exam, either for 8051 data memory or for peak microcontroller data memory. So 8051 data memory is very simple. Only three banks are there. Then bit addressable area is there, and general purpose area is there. The structure is very simple. So here also the structure is very simple. 15 banks are there. So the total memory is 4 kilobytes, and that 4 kilobytes total memory is divided into 16 banks, total 16 banks, and the size of each bank is 256 bytes. The thing is, among that 15 banks, the half part of bank 0 and half part of bank 15 combined together to form a access bank. Okay, and either you want to access the access bank or you want to access the general bank, that depend upon the bit a. If a is equal to 0, access bank will be selected. If a is equal to 1, through bank select register, remaining banks are selected. So here I have taken one example. A is equal to 0, and if the address is 82, it can be selected from this bank, that is the bank number 50. Okay, so according to that, if a is equal to 1, first of all, by using the BSR register, that is bank select register, which is a 4-bit register, from that I have to put the value of the bank. Suppose if I put 0011, bank 3 will get selected. 0011, 0100, bank 4 will get selected. So likewise, right now it is 0010, that's why bank 2 gets selected. But among this bank 2, 256 bytes are there, 256 locations are there. So which particular location user want to access? So one has to provide the address. Suppose 82. So 282 signifies that first letter always selects for the bank and last two letters location from that bank. If it is 482, bank number 4, 82th location. 582, bank number 5, 82's location. Are you getting this? So this is very, very simple thing, and most important thing. Number of times the question will be asked on this part, data memory. So data memory for peak microcontroller is 4 kilobytes. Yes, so the question will be asked, draw and explain the organization of data memory in detail for peak microcontroller. So the most important thing is the diagram. So this is not supposed to draw in the exam. This is just for your understanding, but you can write the information or theory related to this diagram. So this diagram is only important. Okay. So any doubt regarding this data memory organization? Yes, ask me if you are finding any difficulty. So that is available in your Mazidi book also, or you can download the data sheet. From that also they have given the nice explanation about the data memory. The thing is, you can access the data memory by different way. So how the data memory can be accessed, that is shown from the example. I have taken one example. Okay. Same is the case for program memory. So in program memory, the stack levels are there. So stack level 1 to stack level 31 and the reset vector. And then in the program memory, for interrupt, they have just keep the separate location for the interrupt vector. So interrupt vector 008h likewise, and interrupt vector 0018h. Remaining all can be used as a general purpose program memory. Okay. So total 21 bit program counter is available for the program memory. Basically 2 megabytes of memory we can access as far as 21 bit address bus is there, but only up to 1 megabyte of memory can be accessible for this location. Remaining can be just read as a read zero memory. So that is given in this diagram. Okay. So this is just for your understanding. The program memory, most of the cases the data memory will be asked. So but you should know what is the size of program memory, what is the size of data memory, and we can say the structure of data memory or the organization of program and data memory. Okay. Apart from that, in some cases, if the data memory is to be accessed indirectly, the FSR, file select registers, are taken. So according to that you can access the data memory, but the two important things are, you can just access by these two ways. So in file select register, the 12 bit of address of data registers are there: FSR 0, FSR 1 and FSR 2. Again in that, lower byte and higher byte is allocated, and the index register is used in the indirect addressing. Say, just remember in 8051 we have seen the indirect addressing mode. What we have done there, we have used the @symbol. So instead of directly providing the address of that location, we will just provide the indexing, index through the index register, that location can be accessed. So that is called as the indirect addressing as well as the file select register combination. Okay. So see here, instead of directly going to that particular location, through the file select register, it will be loaded the location, and through INDF is the index register which point to the FSR2, and that the FSR2 contains the exact location, and then the particular value at that location can be taken in the particular register. So it is same as that of your indirect addressing mode in 8051 microcontroller. Through INDF register we can indirectly accessing the data memory. And in previous case what we have done is, it can be a direct addressing. See, the name is given direct addressing. Why direct addressing? The bank number as well as the bank location is mentioned directly. So that's why the direct addressing mean. But here the bank name, bank number and the bank location can be associated with INDF register. So INDF is an index register associated with all these FSR register. If I talk about the INDF 0, it is associated with file select register 0. INDF 1, FSR 1. INDF2, FSR2 likewise. Okay. This is as good as your index register. So these are the three ways what I told about the accessing of data memory. Three ways to accessing the data memories: by using BSR, by using FSR, and by using the access bank, that is the A is equal to 0, that is the GPR register. So this is all about the data memory organization, program memory organization. same as that of your 8051 microcontroller. How many registers are available in peak microcontroller? So that list is given, so that is called as a programming model. Very rare this question is asked, but you should know what do you mean by programming model. In programming model, how many registers are available associated with the with that microcontroller, that you should know, and that you should just explain, or that you should just combine in one sheet. That becomes the programming model. Okay, so see, all the registers already I explained: ALU, working register, status register, then BSR, FSR, program counter. So all these are combined in a one sheet. And apart from that, we have seen in 8051 microcontroller some SFRs. So what do you mean by SFRs? Special function register. So special function registers associated with some special features, some special peripherals. So they are associated with that peripheral only. So for IO port, special function registers are available. For interrupt, for serial IO, for timer. So likewise, for each and everything, the special registers are available. They are available in that location. And this is related to the program counter and the data memory register, that is FSR, BSR, then working register. Okay, so this all combines is called as the programming model, so that you should know. So before going for the programming of peak microcontroller, already I told working register is 8-bit working register equivalent to accumulator as your 8051 microcontroller. And what is the job of that is, basically it is used for arithmetic and logical operation, same as that of your 8051 microcontroller. You just if you are remembering a simple program of addition, one of the operand should be in accumulator. Same is the case here. One of the operand should be in working register, and once the operation is completed, the answer, the output is available in working register. And by using the move instruction, you can just move that value to any location in memory or in some other register. Okay, and BSR is a bank select register. It is a 4-bit register. So 0 to F, that is 0 to 15 banks can be selected by using this register. Right now we have studied in data memory organization. Okay, apart from that, this is very very important register. So could you just elaborate this register or correlate this register with 8051? Anyone? Yes, do you remember such type of register we have studied similar to this, not exactly like this? Yes, can anyone tell me which register we have seen for 8051 microcontroller? Yes, similar register in 8051 microcontroller. Hello?
Ma'am, PSW?
Yes, exactly. PSW register. So what is the job of PSW register? The word itself indicate program status register. So what are the flags we have seen? Carry flags, auxiliary carry flag means what? After performing the arithmetic and logical operation, the status of that operation can be shown to the user by using the PSW register. So basically what it does, it shows the status of operation. That's why the name is given as a status register. And here the flag register or the status register is called in peak microcontroller. Okay, again it is a 8-bit register, and the flags are same as that of your 8051 microcontroller. Okay, so again most of the time the question is asked, draw the status register in peak microcontroller for 4 to 6 marks. So the most important thing is bit position, the flag position. So 0th bit is a carry flag. So when carry is generated, the carry flag gets raised. Carry or borrow, for subtraction it will be considered as a borrow flag. For addition it will be considered as a carry flag. The thing is, the different thing in this is, in 8051 we have seen AC, and here it is DC, digital carry, but the meaning is the same. Okay, the it is also the same as that of your auxiliary carry flag, but only the name is changed in the status register. It is auxiliary carry, but here it is digital carry, but the job is same as that of your AC. That is when the carry generated from bit number 3 to bit number 4, this carry flag get raised. Okay, but the name is only digital carry flag. So these two bits are related to the carry. When the carry generated from the MSB bit, that is simple carry flag. When the carry is generated from the lower nibble, that is bit number 3 to bit number 4, that is called as a auxiliary carry. As well as in peak microcontroller, it is called as a digital carry. Again, the zero flag, when the result of operation is zero, this flag gets set. Overflow flag, when the answer is greater than the whatever the limit or 8 according to the 8-bit size, overflow flag gets raised. And this is the negative flag. So all of you know the negative numbers depending upon the MSB bit, so this flag gets raised. Okay, again, this is a very very important flag. This is very very important register. At least you should know the organization of this register, and you should elaborate each and every bit by simple explanation, for by simple example also, according to your understanding. Okay, so this is very very important register. And how you correlate this register with your 8051 microcontroller? PSW register is same as that of flag register in peak microcontroller. Okay, so what we have studied in today's lecture is, as we are taking the lecture after a long time, so the basic difference between peak microcontroller and 8051 microcontroller, what are the extra features available in peak microcontroller, that can be understood by features. So just go to the features in detail. Then architecture of 8051 microcontroller and architecture of peak microcontroller, you should have the comparative study. So what type of comparative study is needed is, what are the common things that is already known, but what is the different thing in peak microcontroller which is not available in 8051 microcontroller, that you should list out. Okay, then there will be a no confusion between the architecture of 8051 and peak microcontroller. Then the registers, what are the different registers available. And then most important thing is, as peak is hardware architecture, the program memory and data memory is different. So that's why the associated address bus and data bus for both the memories are different. So that we have seen. Okay, and according to that, we have seen the program memory organization, data memory organization in detail, and lastly the flag register. Okay, so see, if I think you don't have the ebook for what we can say peak microcontroller. Do you have the ebook for peak microcontroller, or I have just shared for 8051 microcontroller? Yes, anyone can just tell me. Hello, do you have the peak book, peak microcontroller book?
No, ma'am.
Okay, so I will share the soft copy of that. Or one more thing is, do you know? Do you aware about the Nimbus software? The librarian madam has given the username and password. Through that, you can access the ebooks available on that platform. That is very good thing. You can contact to library madam, and you can just search the books whichever you require for the study. And one more thing is, the most important thing is, you can just download the peak ATF data sheet microcontroller, and you can just start studying that peak microcontroller from the data sheet. It's very simple. In a very simple manner, the information is given on that data sheet. So these are the options. But don't just relax ki it's very simple or likewise, because a peak microcontroller is bit simple, as you have studied the 8051 microcontroller. But if you are just combining both microcontroller, there may be a chances of getting confusion between these two. So that's why get the things clear. If you are finding any doubt, you can ask me. So today we will cover only these three topics: data memory, program memory, revision of architecture and features, and PSW register, that is the status register. Okay? Any doubt from your side? Anything which is not understood, or anything you want to be explanation more?
No, ma'am.
Or for practical, I will show the videos. That is, a video means a short videos of just how the nature of output for a particular practical. Because I think I have explained the steps to create a project, to create a hex file, to burn the hex file on microcontroller kit. So that steps are already explained number of times. Still, if you are finding any doubt, you can ask me personally, but try to understand the program on your own. Don't mug up the program. If there is an offline practical exam, then there will be a problem. So try to understand the logic behind that. Try to write the code on your own. The remaining things are very steps only, the manual steps. So the most important thing is you should able to write the code for the same assembly code. I think I have given the code for LCD, I have given the code for LED, and then the 7 segment display. Remaining codes I will share. So at least if you have the kill platform, just try the steps up to creating a hex file. Whether you are getting some errors, try to sort out the error, try to eliminate the errors likewise. And then up till getting the hex file, you can do at your home. And the next procedure is just programming or loading the code on the microcontroller kit, as you don't have the microcontroller kit. But this much part you can do at your home. That is my appeal. Okay? So any confusion, any doubt, or anything you want to ask?
Ma'am, can you
Otherwise,
just repeat the name of the data sheet that you mentioned?
just pardon.
What is the name of the data sheet you
You
mentioned
can
just?
just Google on Google platform data sheet of peak 18F. Or otherwise, if I have that data sheet, I will send it on mail. You can just type
Okay.
peak 18F data sheet, and in data sheet everything is given related to the architecture, related to the memory organization, related to the all features, suppose timers. So what are the SFRs related to the timer in peak microcontroller? Now here onwards, you have to just study the registers, that is the special function registers. For timer they are different, for serial communication they are different, for interrupt they are different. So likewise, only the organization and their meaning, and that all information is available on the PDF. Otherwise, you can go for the Nimbus software. You can contact to library madam. Madam will help for the same. I think you have to log into that, and the number of resources are available according to the branch wise, and you can access that material from your remote location. Okay. Just tell me your number one by one. That's it, because only 19 students are there. So it will be better to just tell me your numbers one by one. Today is one. No?
I'm roll
Okay.
number 4.
Roll number
I'm
four.
roll number 3.
Roll
I'm
number.
roll number 6.
Okay. हाँ.
I'm roll number 3 हो गया.
हो गया.
Number
6.
4.
6.
I'm
रोल
roll
नंबर 3 हो
15.
गया, 4 हो गया, 6 हो गया.
I'm 15. 15.
Okay. Okay.
Ma'am, 18.
Hmm. Okay.
59.
59. Okay.
26.
63.
Okay.
69.
44.
63 is okay. Huh.
44.
66.
44.
Yes, 44.
Okay. Hmm.
66.
Hmm.
47.
One at a time. 69 is okay.
47.
47 is done. Next.
60.
60.
60. 60.
Okay, done. Yes. Remaining student, please tell your roll numbers.
77, ma'am.
Yes, 77 is done. Next. Tell me your roll numbers. Otherwise, I will leave the meeting. Everyone is done with the roll numbers? Yes?
Yes, ma'am.
Still number of students are not answered.
Ma'am, 26 present.
26 I have done. So should I leave the meeting?
मॅम 74.
काय करत होता जय?
सॉरी मॅम, ते फ्रेश व्हायला गेलतो.
काय तरी सांगता रे.
Ma'am, 78.
Next. Those who have given the attendance, they can leave the meeting.
Ma'am, 78.
Done.